Hi guys, welcome back to my math YouTube channel. In this video, I want to talk about the derivative of exponential functions. So guys, the very first thing that I want to make sure that everybody gets it correctly. The first thing that I don't want any one of you to think or do is that the derivative of an exponential function of the form b to the power x is x b to the power x minus 1. So guys, that is something that I don't want people to do because that is not true. So sometimes I see students think of this also as like a power rule, but guys, we cannot use the power rule on an exponential function of the form b to the power x. Why? Because for the power rule, what we have is we have x to the power n, but n, well, this looks like an exponential form, that is right, but n is a constant exponent, okay? So in this case, guys, for this particular x, it's not a constant, right? So we cannot use the power rule to find the derivative of an exponential function where we have n variable in the exponent. Guys, here it seems like we have a variable, but we know that n stands for any particular number. It could be a fraction, it could be a positive or a negative integer, okay? So please do not do this. Now what we have to do here is we're going to find out if there is any other ways of writing or finding the derivative of the exponential functions. And guys, of course, one can go back and use the limit definition to see that, or there's a simpler way actually to derive or to find the derivative of exponential functions. So I'm going to show you the general way of finding the formula for the derivative of an exponential function of the form b to the power x. So that would be our general formula. We'd also calculate or evaluate the derivative of an exponential of the form e to the power x, and then we will use those two and one more, which is also like a consequence of a chain rule, to actually evaluate the derivative of different types of exponential functions. So guys, in order to evaluate the derivative of an exponential function of this form, one of the ways, as I already told you, is to use the limit definition. Guys, the other way is to actually use the idea of logs. And I'm going to illustrate, I'm going to derive that using the idea of the logs. It's really easy to see it from the logs. And we already have talked about the logs, and and we're supposed to know some of the basic properties of logs as well. So what we are going to do is, guys, let us start with, say, we want to find the derivative of y. We want to find the derivative of the exponential b to the power x. Let us say that is equal to y. So what I'm going to do to both sides is I'm going to apply ln to both sides. So if I apply ln to left hand side, obviously I have to apply the ln on the right hand side as well. So guys, keep in mind, when I apply the ln on the right hand side, this looks like a power rule for the logs. So this will be simplified as x times ln of b. I'm just using the power rule for the logs, where you have a log of m to the power n, you bring the n in the front and you multiply by the log of the m, and in this case it's just you bring the x in the front and multiply by the ln of b. So let us take it from here. We have this guy, log of ln of y is x ln of b. Now if I apply the derivative on both sides, or if I take derivative on both sides, what's going to happen? Guys, if I take the derivative of this, we know the derivative of an ln function is the inverse function, but we cannot just stop right here because this also is a function in terms of x. So we got to use the chain rule here. By using the chain rule, we just have to do the dy over dx, right? That is how we take the derivative of the left hand side using the chain rule. Guys, on the right hand side, I'm not going to just do this. I'm now going to look at this guy right here after using the property of the logs. Finding the derivative of this is pretty easy. This ln of b is just a constant, right? Because we know that b is supposed to be any constant number, right? So what we have to do here is we just have to find the derivative of x, which is just 1, right? So it's just going to be ln of b times the derivative of x, which is 1. So I don't even have to write that 1. It is just ln of b, right? Guys, from here, what I'm interested in the first place, I was interested in finding the derivative of this function. That means I was interested in finding dy over dx. So in order to find the dy over dx, all we need to do is we got to multiply both sides by y so that we get rid of these y's and we isolate dy over dx. So if I multiply the left hand side by y, I got to multiply the right hand side as well. These y's will cross out. From here, what I get, let us write it over here. I get dy over dx, which is also same as y prime. These are both different ways of expressing the derivative of a function. And on the right hand side, I have y times ln of b. But what is my y? Y is just simply my exponential function b to the power x times ln of b. So guys, this right here is my general formula to find the derivative of an exponential function of the form b to the power x. So let me let me get rid of this and let me write the final form here. So the derivative of an the derivative of an exponential function of the form b to the power x is just b to the power x times ln of b. That is number one. Then number two, which is just a consequence of that, is what if we have to find the d over dx of e to the power x. Again, we are going to use the same exact rule for that, or we can also set it up like this, apply the logs on both sides and use the property of logs and finally find the derivative. Or one can just go back to this rule, and according to this rule, guys, let us quickly try to see what is really happening here. Guys, when we find the derivative of an exponential function of the form b to the power x, you get basically the exponential form right back. You get b to the x back. All you have to do is you have to multiply by the ln of that b, whatever that b is, okay? So in this case, guys, we do the same thing. The derivative of e to the x is just e to the x. One has to multiply by the ln of this e. In this case, b is e. But we know that the ln of e is just 1, so it's just equal to e to the power x. That becomes our second general rule. And guys, the third one, which I don't like to really think about that as a rule, but guys, that is just using the chain rule. Okay, I'll still write it here because we should try to understand that more than just trying to remember that. All we should remember or try to remember is these two things, and even for that matter, just this one. This is just a consequence of that. Guys, the third one, which you can think of just as a chain rule, is if I have to find the d over dx of something like let's say b to the power u, where u in turn is a function of x. So there's a composition going on here, and we know whenever we have a composition or composite functions, we have to use the chain rule. So guys, the first thing we're going to get is b to the power u. That's always going to be true, then times ln of b. But we cannot stop here. We still have to multiply by the derivative of the inner, and in this case, it's going to be derivative of the u with respect to x. So guys, these are the three rules that one needs to know or in order to actually evaluate the derivative of the exponential function. So guys, please keep in mind, never do this when you are dealing with exponential functions where you have a variable like x in the as an exponent or a power. Please do not use the power rule for that. Power rule is only valid for constant exponents, right, of the form x to the power n. And then to evaluate actually the derivative of this function, guys, we can use the limit definition, and you should check that in your textbooks. But we can also use a simple idea of applying logs on both sides, because we already started talking about the logs in my previous videos, so we know what the derivative of the log function is and how to use the chain rule to actually find the derivative of the log functions. So we have this on this side, and then just by simple mathematical manipulation, we are able to find the derivative of the exponential function. Once we have it for the general case, for any b, then we can also evaluate it for a particular b equals to e, and then of course we can use the chain rule. So guys, this is the general form. In the next videos, I'm going to take up some examples and I'm going to solve some examples. Till then, take care. I will see you next time.